So this is part 3 of the example. Now what we're going to look at next is solving for the specific humidity. Now, something you need to know when you see the word specific, sometimes it usually implies that you're dealing with a quantity that's going to be in per kg, maybe something per kg. So if we say specific volume, it will probably be meter cube per kg, but in this case it will actually be grams per kg. So unlike relative humidity, this one actually has a unit that you're going to consider. Now of course, anyway, I won't get into the details of that, but anyway, let's continue. So there are only two main things you need to know here, at least one main detail and another sub detail. The main thing you need to know is your specific humidity, which is given by the symbol W in a textbook of refrigeration and air conditioning, is given by 0.622 multiplied by the partial pressure for the water vapor over the total pressure, the isobaric pressure, P sub B, minus that partial pressure. This is your expression, the units being grams per kg. Then the sub detail you need to know is how to arrive at these very units, which I'll discuss at the end of this question, or towards the end. So we've already determined what some of these values are from the previous videos. Now our PV is equal to 0.01701 bar. This is our PV, and our PB was actually given, and then we calculated it in terms of bars, and it was equal to 0.98642 bar. So these are the values we're dealing with here. So now we plug in these values to get this 0.622 over 0.01701 over 0.98642 minus 0.01701. Mind you, these quantities are multiplying, then these at the bottom are subtracting. So after we calculate, we find our answer to be 0.0914. Now there's something I want you to understand about this quantity we found here, and that's the fact that it's supposed to be in kilograms per kilogram. The reason for that is when you perform a dimensional analysis on what's going on here, you find that your pressure was in bars. Bars is simply 10 to the power 5 and 10 to the power 5 here. This is bars. Now the bars cancel out, and you're left with what's this, Newton meter squared, Newton per meter squared. This is what you have. This 10 to the power 5 times this makes up a bar, but when you cancel out the 5s, you remain with this. Now this and that cancel out, but you remain with your Newton over your Newton. Your Newton is force, so force is equals to mass times acceleration. So you're going to find that you have kg multiplied by meter per second squared. So it's actually kg multiplied by meter per second squared, kg multiplied by meter per second squared. So the meter per second squared and the meter per second squared cancel out, but for the interest of what it is that we're calculating, we don't cancel out the kgs yet, so we keep the kg there. But if you remember, I said the unit for specific humidity is grams per kg, so that means this kilo here has to leave, and we just remain with grams per kg. But we know that kilo is actually 10 to the power 3. So that means we can replace this K with 10 to the power 3. So we're going to have 0.010914 multiplied by 10 to the 3 grams per kg. Have you seen what's happening here? Or you can say multiplied by or something like that. It doesn't really. Then that means your final answer will be 10.914 grams per kg. And this is how you report a value for specific humidity. Thank you.